Hello students, today we will be going over 17.2 congruency, and our objective today is I can show that two triangles are congruent if and only if corresponding pairs or sides and corresponding pairs of angles are congruent, also known as CP-CTC. Okay, so we have some vocabulary here. We have an included side, which is the common leg of two angles, usually found in triangles and other polygons. The included side is one that links two angles together. For example, here you have an angle, here you have an angle. This is the included side. Then we have an included angle, the angle made by two lines with a common vertex. So we have two lines here, and here's the angle made by a common vertex. Vertex is the point where these two lines meet. So that would be a vertex at point B. Okay. Included and opposite. Side LB is included by angle L and angle B, the angles whose vertices are the endpoints of the segment. Angle S is included by LS and BS, the segments which form the sides of the angle. B lies opposite LS, so LS opposite is B. BS lies opposite angle L. So right here, BS is opposite angle L. Okay, so we fill in this part, the side opposite angle P. So in other words, if you were sitting in this corner, where would you be looking out at? And that would be AL. Okay, and make sure you put a bar over here that shows that it's actually a line segment. Okay, the angle included by AP and LA, AP, LA, both included would have to be angle L, and I'll put it just like this. Okay, the side included by angle P and angle L is line segment PL. And again, put a bar over that, okay? The side included by angle A, and actually I'll let you do this kind of on your own because I think you can do that. This one's a little more difficult, so I'll help you through on this one. In triangle BET, the side opposite angle E is, so if you're sitting in corner E, the side opposite would be BT or TB. Either one, it's the same line segment. Making sure you put a bar over there. In triangle SAT, right here, the angle included by AT and TS is obviously going to be, and for this one, we can't just name it angle T. If I was just going to name angle T, I wouldn't know if I meant right here, over here, here, or here. So we have to use three letters to signify that this is the one that we want. So I would actually say on this one that it would be angle ATS. And so this is my angle sign right there. The segment included by angle A and STA is going to be angle, the line segment would be AT. You could also put TA, and again, you want to make sure that has a bar over the cross of it. Okay, go ahead and do 4, 5, 6, and 7 on your own. And now we're going to fill this in. Triangles with the same what? Okay, this I think you can get from the definitions before. So you have to fill that out, but I'm not going to do it with you. Okay. When triangles are congruent, we can write congruency statements. That's to say, and we see that triangle ABC is congruent to triangle DEF. So we can see that angle A is congruent to D, angle B is congruent to E, angle C is congruent to F. So since this has one, over here, whichever has one arc matches up. If this has one little mark here, this has one little mark, we can say ED is congruent to AB. Same with like AC, see these three little marks? That means it's congruent to FD. So those are exactly congruent. And what is congruent to angle B? And that's correct, it's angle E. And what side is congruent to FE? So FE, what's congruent to that? BC. And now if you said CB, that is also a correct answer. Okay. Next, CPCTC. What is that? It stands for corresponding parts of congruent triangles are congruent. Okay? If we know two triangles are congruent, then we know that every pair of corresponding parts is also congruent. So basically that's what that says. So if we have triangle JKL congruent to triangle PQR, we say corresponding sides. So we could say that JK, just kidding, JK is congruent, and I just put equal. You'll have to put congruent to PQ. And then we could also say, let's go over here, corresponding angles. We would say that angle J is congruent to angle P because they have to line up here. And I will let you fill in the rest of this. Okay? Now, if it says given this triangle, find each missing measure. And I think I'm going to let you do that one. Know that angle H is the same as this one, and know that since these two sides are the same, these two sides are going to be the same. And we can say every triangle adds up to 180 minus 38, and then divide by 2, and then you'll get angle G and angle J. I wanted to do a little bit harder one, which would be this one. So, actually, maybe I'll do angle H over here is going to be 38 because it matches this angle right here. Then we can say, okay, 180 minus 38. Let's see, what does that equal? Is that 42? So if I take 142 actually, and if I divide that in 2, it's going to be 71 degrees, if I did my math correctly. So we know that these two are both 71 degrees because it's an isosceles triangle. Okay, then we can say if this is 27, then this side has to be 27. So we can go, let's see, GJ, GJ right here. Since that's 18 feet, this is 18 feet. XY is going to be 27 feet. And ZY, also 27 feet. And we're done with that one. Okay, I'll just set this one up and let you finish it. Okay, we say that these two triangles are congruent. That's we're given. Now we have to find the values of X, Y, Z. Okay, so we know that H is congruent to N. So we can say that 6X minus 29 equals 115. Okay, then just solve for that. And then Y, after you've solved for X and you know what this is, you subtract it from 180. So you subtract 36 and whatever you get for H here, then you'll get S. Once you have S, you can say that this S is going to be right here, whatever that one number is. Oh, maybe I better finish this. Okay, I'm trying to keep these under 10 minutes, but it's not happening. So we add 29 to each side. So we get 6X equals 144, and then we divide by 6. And we divide by 6 over here. And 144 divided by 6. We see that and x equals 24. So then we go 6 times 24 is 144. Minus 29, and we get 115. So we say angle H equals 115. Okay, so once we know that, which I could have just done here, that this 115 has to equal that, but we needed to figure out what x was because they asked us for that, okay? Now we can say that angle P equals 36 degrees. We can add those two together, and then we know that the last one, angle S, let's see, if we add those two together, we get 151. Would that be 29 degrees? Okay, we also need to make sure we know what y is. So then we set that up to 3y minus 1 equals, let's see, angle F was the same as angle S, 29. Okay, solve for that one. And then the last one for z minus 32 equals 36. Okay. Solve for y and z, and then you should be good. Good luck, students. You rock.